Let's take a look at one way we could approach this problem. So we've got in your totally dark bedroom, you make your way over to your dresser. You still need a pair of socks for the day. You don't want to turn on any lights, and your socks are just loose in your drawer. You know you have 3 pairs of black socks, 2 pairs of brown socks, and 4 pairs of white socks. What's the minimum number of socks you should grab so you'll be sure to have a matching pair of socks? Okay, so what we're really trying to figure out here is how many of those socks do we need to grab so that we can be sure, no matter what, we've got a pair of socks and we won't have to go back into our dark room to get more socks. There are lots of ways to do this, and the key thing you should end up realizing is something like the worst case scenario. So you guys want to have worst case scenario on your head when you're solving a problem like this. I wanted to show kind of a different way to do this rather than reasoning and tables and stuff like that. So instead, I made a little sheet here where I've got all of my possible socks. Okay, so I'm going to use manipulatives and then a little inductive reasoning. So I've got, here's my 3 pairs of black socks, my 2 pairs of brown socks, and then my 1, 2, 3, 4 pairs of white socks. And what I did was I cut those out. So I've got, just a bunch of random pieces of paper that have colors on them. But this is the right ratio for my drawer. And now what I'm going to do is I'm going to grab socks at random here, and we're going to figure out what happens. So I'm going to do a bunch of trials. So trial 1 here. Let's grab some socks. So I'm just grabbing these at random. I've got, looks like a white. I've got another white. Okay, so I'm done. Trial 1 took me 2 pulls. Now, I could stop there and say, well, I think it takes you 2 tries. But instead, since I'm not actually using direct reasoning here or anything, I'm going to repeat this experiment again. Okay, trial 2. Let's see, I've got a black sock. I've got another black sock. Okay, 2 pulls. Let's go again. So trial 3 here, I've got, a white sock. I've got I grabbed 2. A brown sock, a black sock, and a white sock. That took me 4 pulls. Okay, let's try again. And the real key here is I'm just trying to get enough data so that I can guess what the rule is, right? So I can use inductive reasoning to finish off the problem. Okay, trial 4. There's a brown and another brown. Trial 5. I've got a white, a brown, a black, and a black. Okay, that gets me a pair, so that was 4 pulls. Let's just do 2 more here. Trial 6, there's a white and a white, so 2 pulls. And trial 7, I suppose I should do 8. That'd be a nice round, even number. Black, black, so 2 pulls. Okay, and then one last time. Got a white, a black, and a white. That was 3 pulls. Now, this is a pretty, okay, so there's some trade-off here. I could have written a program that would have done this for me, 10,000 times, but that program would have taken me longer than it took me to cut out those pieces of paper and just pull 8 groups of them. Okay, so if this was something I wanted more, imperial or observed probability or statistics on, maybe a program would be good. To do the program, you've got to know what you're looking for, right? You've got to know what you're looking for, what the parameters are, all those things. But there, I did a bunch of trials. Now, remember, we're looking for what is the smallest number we can pull so we are sure we have a pair. I had quite a few trials, surprisingly to me, where it only took me 2 pulls to do this. However, I had a few trials where it took me more than 2. So if I said the answer was 2, I'd be incorrect because right here in trial 8, it took me 3 times. Similarly, in trials trial 3 and 5, it took me 4 times. So it's possible, or so it appears, to pull out 3 socks and have them not match, but every time I pulled out a 4th one, I got a match. Hey, that sounds like a guess at a rule. And we could extrapolate farther as to why we think that works and the numbers of socks and things like that. But our real answer here that we can guess inductively, our rule is we need at least 4, because we've got 3 different kinds of socks, and we did a bunch of trials to check. We've got 4 pulls should get us 1 pair of socks. We don't know what color that pair is going to be. Here in trial 3, they were both white, and in trial 5, we had a black pair. And who knows, if we grab 4 socks, we could or 4 pair socks, we could end up with all kinds of things. But to be sure that we've got a pair, we're going to have to go for 4 pulls. At least that's what my inductive reasoning tells me from observing these trials and trying to guess this rule.